Okay, let's get going. Welcome, everyone. Thank you for making the trek down that very long corridor. This is the start of the Khronos BOF day in the afternoon on the Wednesday of SIGGRAPH 2023. And watch out, because glTF is in town. We have a 2-hour session where we have a number of speakers that are going to give us a deep dive into a number of different aspects on glTF. And we're going to start out with Alexey from Meta, who's the chair of the 3D Formats Working Group. So over to Alexey.
Yes. Oh. So yeah, we'll do the short overview of the current glTF state. Okay. Yeah. So glTF is part of 3D Formats Working Group, and you can see on the slide what we're doing. In general, it's a glTF spec itself, which includes PBR, and the new extensions, they're actively in development nowadays. Interactivity, composition, KTX, physics, geospatial tooling, and tutorials. Some of them will be covered later today really deep, so I will not touch them in my topic. So, sorry, missed this. So, what is glTF? glTF, it's a spec for a file format, which intended to be in transmission effectively format to provide the information between authoring tooling and actual viewers on the different platforms. The goal for glTF open standard actually just not innovate on pervasive deployment or, innovate on pervasive deployment of proven technology. We are not inventing the wheel. We're just like taking the best from industry, distill it to the best representation and provide this as the spec. And this is precise specification, and we provide the open source tooling for multiple vendors consistency as well. By glTF, we enable cloud, desktop, and mobile development, so we pretty much platform agnostic. It's a pure file format. We don't mandate any runtime behavior for anything. We heavily optimize for runtime and use cases, so that means most of the data directly maps to the internal representation for GPU. And we want to be cooperative between the DCC tools and the authoring formats and this last mile format. As you can see on this image, basically that's how we think our spot for glTF is. Also, last year we were approved as the ISO IEC JCC1 standard. So the goals of adoption. We picture glTF as JPEG of 3D. That means we distill only necessary information to be effective for the final runtime viewers. Again, it's a completely platform agnostic and pervasive as much as possible. But we are not 3D format for the models anymore. We are format for 3D assets. That means it includes the other property, including audio, physics, and possible in the future something like anchoring, haptics, etc. We'll just describe the properties of the general 3D assets, virtual 3D assets. We picture our adoption as we have the glTF core spec. That means each runtime should respect the core spec and implement all the features. And we have the extensions that you can extend your functionality for particular use cases. And on top of this, you can build your experiences. So this is a work in progress for us. Several extensions are already in the ratification process. Some of them are really close to be ratified. And so basically that's the list that you can see what we are doing at this moment. KTX is another big direction for 3D Formats Working Group. KTX, it's a hardware-independent compression format that allows you to compress texture information as much as efficient as possible, and then be able to transcode it to the final hardware texture format on flight. With this extension, you will be able to reduce significantly memory impact for your assets, but still preserve hardware efficiency for the GPUs. One of the actively developing extension is a physics. We want to provide platform-agnostic way to describe the physical properties of the objects, be completely physics engine detail independent, and the current goal is provide two extensions, which one is will provide the collision information that can be used for different purposes, even outside the physics implementation. And the other one, it's an actual rigid body implementation that includes the motions, rigid bodies itself, joints, filters, etc. Another significant direction for us is geospatial. We signed the liaison with the Open Geospatial Consortium. We're working on the geospatial industry needs and finding the way to provide the way to extend the large data set support in glTF. It includes several extensions that I listed before, as the GPU instancing and mesh compression. Includes point clouds as well, and we working on hierarchy LOD extension. And this is slide basically our vision for glTF tomorrow, how we picture it. Some of the extensions are already in progress. Some of them such as anchors and haptics, they planned for the future. The really important part of our collaboration with inside the Metaverse Standards Forum is be able to be interoperable with the USD format. And we spend a lot of effort to find a way how we can interchange the data between USD and glTF to close the gaps between authoring tool and delivering format and be friendly for any different experience for the metaverse. We spend a lot of effort working on the education and the videos and tutorials. We implement several open source projects. We produce a lot of videos to educate how to use different formats, including glTF, KTX, how to optimize your assets. Yeah, please take a look on our website and YouTube channel. And we definitely here to hear your ideas, what we are missing in glTF and what you want to see in the future. And this is our short-term roadmap. Next incoming extensions, most likely the first spec for behaviors, that will cover it later today. Also audio and physics. Also we have PBR incoming, but Ed will cover this soon. Again, if you have any ideas what we have to put here, please let us know. And that's pretty much it. I have Dan Frith, who is the chair of 3D Commerce Working Group. He's next.
Oh, that's quite low down. Hello, my name is Daniel Frith. I work at Avataar as Vice President of 3D, and I'm Chair of 3D Commerce and Vice Chair of 3D Formats. Today I'm going to take you a little bit through how to level up 3D Commerce and where we are in regards to e-commerce and glTF and everything. This button does not work. Okay. Right, okay. I'm just going to lean across here and press this button. Oh, no, there we go. Right, sorry. So the Khronos ecosystem has different segmentations. There's multiple Khronos standards that are all relevant to developers with similar requirements. But today I'm going to focus on the pervasive 3D segment, which is where glTF and 3D Commerce and WebGL and KTX all reside. And this is to do with like how glTF is used in that section. Oh, where am I going? Spacebar, thanks. So the glTF ecosystem, just to give you a summary of what this is, we've got glTF in the middle. There's a whole load of different types of experience that use glTF as the core and support glTF. Then you've got different commerce companies, like such as the ones at the bottom there. And we have lots of creation tools as well, which go with that. And then, of course, you can also download assets and discover glTF files and PBRs and everything from other platforms like Sketchfab, TurboSquid, etc. So, but today, just down the bottom here is more where 3D Commerce resides, and I'm going to tell you a little bit about how 3D Commerce and glTF work together. But before I do that, there should be a little video here that kind of gives you an overview of the kind of things we do. There is no audio, no. There was a bit of music. I can hum. We have, obviously, glTF and PBR are used a lot in virtual reality. And then, of course, a lot of e-commerce retail companies such as Target use 3D, well, glTF and PBR. And then, of course, those assets are viewable in AR. If you take the watches here done by Bremont, then, you know, IKEA, you've got, I don't know, the majority of the content in IKEA now is available in 3D, and glTF is the primary format for that. We've got different planners that use glTF and PBR. And then, of course, you know, this is the core of a lot of these companies and how they're working, how they're getting assets together to make them usable. Configuration and switching between different PBRs, different glTF files. Bed configurator that we did at Avataar, and then there's different interactions as well, and Gerald's going to go through that a little bit with you later. And then, of course, you've got things like different underwear, but Ventana did this great thing here for Diesel, where they could like customize and see it in AR as well, and install clothing there, and more AR and VR examples for you. Actually, I'm going to move on. So the point is that there's a hell of a lot of industry support for glTF and 3D Commerce. A lot of companies already support glTF, and glTF is actually becoming stronger and stronger and more prevalent and very much pervasive in the e-commerce industry, where a lot of companies are basically relying on glTF to be the standardized way of working. So just to take you through something on that video should be playing, but it's not. Okay. So for example, with Target, you can go on their website, you can click on a lot of their product, you can see 3D representations of those assets in there, and of course you can often see those in AR. And like IKEA, as I said before, I've been doing it for years, and then a lot of the assets there. And we've seen a huge amount of conversion and retainment on websites when people are using 3D as their way forward, because it gives customers a sense of, hey, I can move it around, look at the back, look at the sides. And it's a very important way of connecting in the current way, you know, and especially with the new demographic who are much more technical savvy. We take the word, oh, okay, these videos don't like playing today. And then, for example, you can get like a really high resolution, high definition on a lot of these assets. And glTF is a really good way of like bringing out really nice shaders, different extensions. There's a PBR presentation by Ed in a moment, which he'll go through quite a lot of the different extensions we're doing in PBR. And the way e-commerce works and the way 3D commerce works is that we're looking at the business needs and the use cases and how we meet customers and how we build experiences for customers. And then we're taking those findings to 3D formats and PBR and interactivity and saying, you know, hey, we really need this. And then the idea is that we then build an ecosystem with glTF at the core and the center, but the business is going to need these assets in this way. If you take like the work with OpenUSD, for example, right now, you know, how does that implement? How do we work with that? How does glTF fit into this ecosystem? So, but from 3D commerce perspective, we've got a business need that we need to fulfill to convert more customers. So, I mean, another example here is like bed configurators. There was a huge conversion rate here with Sleep Number, where suddenly customers be able to configure and actually put heat mapping on these beds. Made a huge difference to their traction, made a huge difference to their revenue, and actually it meant that some companies are seeing, actually, if I go to the next one here, oh, actually, no, I'll come to it in a second. But like with Ventana, this enabled Diesel to be able to represent their products in another way through AR, so you could actually see it in your space. I mean, it didn't have virtual try-on, but at least, you know, you're actually able to see the product and go and zoom in up close to it. And so one of the most important things about glTF and PBR is that it's creating that consistency in that color so that you know that when you receive that product in real life, the physical to digital consistency is always there. So this is what I was going to come to. So the work Epigraph did with Ace Hardware, which I presented and went through the other day, they saw a 405% increase in revenue on a lot of their products when they were using 3D assets, and they saw a 500% increase in people staying online, which is pretty impressive and would make a massive difference. And I think the thing to emphasize is that Ace Hardware as a company are fundamentally a hardware company, silly thing to say, but the point being is that they've not really been in the 3D space before. So suddenly to have 3D as their way of working hugely changed a lot of things, a lot of their customers, and it also meant they attached to a lot of different demographics. I haven't got the AR footage in here, but you can then put these toolboxes that they've done into your garage and adjust them. You can customize them, and you can actually see them in place. And then virtual try-on as well, where that glTF files and again shaders and putting these different Nike trainers on. I think this was using Snaps Tech, and then putting these assets onto your feet. You know, it's really helping people connect and sort of say, I can see how this is going to work on me. This is my kind of product. You know, it makes a huge difference in that kind of physical to digital presence. And then I've got also here like footage of Wayfair's room planner. So this is an interesting case because obviously you've got a lot of multi-SKU items and it's all about resolution. You've got to keep the resolution up, but there's a lot of assets in that room and you can keep adding to it, and it's keeping it efficient. And this is where glTF is really good because it's an efficient transmission format. So building these assets in glTF and having a central core of assets of glTF files means that Wayfair can then put these assets and lower resolution versions of into these planners. And then this was something that was done in IKEA a while back, and it was a VR experience where actually you could configure rooms and build a whole like VR experience and actually put places and change wallpaper and change different products with pictures on and everything else. And again, that transmission speed of glTF and the VR experience and actually being able to put multi-items together in there, the glTF was the only way to go with PBR. So again, I've already mentioned this, but the importance of standardization is getting as close to the real thing as possible. And glTF is a really good way of doing that. It's probably the best way of doing it because it's going to allow, we've seen an e-commerce conversion, online duration. Oh yeah, and I didn't really emphasize it, but Epigraph with Ace Hardware, they saw a massive reduction in returns because it meant that customers were getting exactly what they saw online. So when they were ordering it, testing it out in AR and seeing it, moving it around, they had a massive reduction in returns, which is fantastic. And then obviously load time, you can't always guarantee that someone's got a decent device and you can't always guarantee someone's got a decent bandwidth. So glTF, and what we do is a really good way of transmitting information. It's very efficient because it's based on the JSON format, and it's like minimizing the size of 3D assets and the runtime processing, which is great. And then, of course, the use of standardized file formats is providing consistent experiences, like all the examples I've just shown you. It's very important that those photographs or those physical products look like that in real life when you get that digital version. Even if it's in VR or MR, or it's in a web browser, or it's on your mobile browser. And then, of course, it's important to have, in regards to physics and scene composition and interactivity, when you compare that to original 2D image techniques, 3D is giving people that kind of really feeling of like something tactile. They can actually see it moving, they can see it interacting, you can actually do stuff with it. While a static image, you don't get that sense. It's really hard as well to get a sense of size and scale as well. And then one more thing was like, I've written here metaverse and wearable AR, because there is a new demographic coming. I've referred to it a couple of times, but my dad still can't get his head around AR, but my 9-year-old daughter can. So there's like a whole new demographic coming that understands technology, understands mobile, understands what these things mean. And as headsets become more available and they become more affordable and they become more accessible to everybody, 3D is going to become the way of communicating your product, full stop. And then just lastly on this part, there's the viewer certification program that we run in 3D Commerce, where if you've got your own engine and you get it certified by Khronos, we can test the glTF files. There's a load of descriptions, specifications that help you do that. And the great thing about this is that we've seen companies who get the viewer certification program, they get actually other customers coming to them saying, hey, we know your engine's going to be guaranteed that the physical product's going to match the digital product, and they're going to get those really good experiences. So to a little bit about what's next, and under development and exploration, Patrick's going to take you through the skeletal facial work that we've been doing, which is really cool. I won't go into that too much detail. Patrick will do that. We got asset creation guidelines. We need to continue the work we've been doing there already. There came up a question, I think it was yesterday or day before, about how do we create consistency of asset creation. So we need to continue the work we do there. And we got scene composition. I mean, Alexey mentioned it earlier. We're now looking at how you build multi-SKU items in glTF and bring multi-items in together. And obviously from a 3D commerce perspective, that's really important to us. How do we bring multiple items into a scene, configure them, but still keep it efficient? And obviously we want to bring interactivity and physics into that if we can as well. The viewer certification program, we continue to evolve that, we continue to develop that because of course things change. There's more, like I said, about headsets, that's becoming more readily available. And as we see that evolving, we need to make sure that the viewer certification program can attach to those other wearables as well. Interoperable tools and standards. We already developed things like the glTF asset validator and the sample viewer, and there's lots of different tools that we develop where you can check your glTF files, you can check the validity of how good they are. It really helps if you throw a glTF file through those, because then you can evaluate how efficient they are, whether there's any problems, because there can often be bad scaling issues, for example, in a model which you don't necessarily see. Tutorials, guides, and videos. We're doing more of those, which is great. We've got more coming towards the end of this year, and we'll be continuing that work we do there, where we're also going to get maybe one-on-one interviews or going to get companies to explain end-to-end. We're going to get people who work in commerce and formats to actually do more tutorials and take you through a step-by-step guide on how to do things, like download a glTF file, assign a PBR. Like Eric did some great presentations yesterday about iridescence, and it's those kind of things we're going to continue to do. We've been looking at generative AI in 3D and neural radiance fields and AI machine learning. It's still quite developmental, but it's something that is happening. It's something that's happening more and more. People are talking about AI and machine learning in 3D and how does that attach to what we do. It's still quite early, but it's something we're keeping a close eye on. And then lastly, industry involvement. So in 3D commerce, we'd really like to get more industries involved. We've got a lot of retail companies, a lot of companies involved in 3D commerce and Khronos, but we'd actually like to get more insights from apparel, automotive, architecture, gaming, because they're all using glTF, but it'd be really good for them to contribute to what we're doing in the 3D formats working group and 3D commerce. I think... Oh yeah, so if you want to be involved, if you want to know more about what we do, here's some links, and you can have a look at that and then see more about what we do. And then now I hand it over to Patrick.
Thanks, Dan. As Dan mentioned, my name is Patrick Hadley. I'm on the AR product team at Snapchat. I'm also a chair in the skeletal and facial anchoring on the 3D commerce. We just want to do a quick introduction on some of the work we've been doing on body anchors, as well as virtual try-on in the Khronos group. So before Snapchat, I actually was working at Amazon back in the early days when they were just starting into the 3D space, and we tried to get some 3D models from other suppliers, other brands and partners, and it really was a challenge because we had our own material library, texture library. There was a lot of other challenges that was just there to make it interoperable, very challenging. PBR and glTF really did change that. It made it very easy to kind of have interoperable products that are focused on furniture, so you can have a consistent, high-quality product each time, and then you had to just worry about the lighting environment and how you represented it. But really, a lot of glTF so far has been focused on the product itself. And it makes sense because if you're going to place the product in the room, something like furniture, there's really just a few choices that you'd have. So if it's on the floor, you put it on the bottom center as the pivot point. If it's on the wall, you put it on the back center. On the ceiling, it's the top center. But as we move to more complex interactions, specifically with the human body, those don't always work. At Snap, we've been taking in 3D models of glasses, footwear, different stuff we have virtual try-on for. And if it's on the bottom center, some of them will be in the center of the object. There's really no standard right now. And what happens is people have to manually adjust the transforms to fit it on to the face. If you have different size glasses, you can't have a single transform. We tried to have single transforms. So there really was a problem in the industry of that interoperability for that 3D to human body interaction that we saw. We worked, one of them we announced earlier this year. It was with Amazon. We brought in 7,000 of their assets and worked a little bit on this same problem. So we took this to a Khronos 3D commerce to solve this challenge for the industry and see what we could do to generate some standards for interoperability. If you look, a couple things, it's just like the placement. It doesn't look that bad with the glasses, but it definitely throws off. Like if you're trying to make a purchase, it's very an emotional purchase, so it doesn't necessarily look good. Or with the shoes, if it's not fitting correctly or if you have clipping on the sides. So our goal with the working group was to really develop a standard or a format, a framework that would be consistent as well as kind of an optimal best fit. It was easy to use for 3D artists and for people to understand, and it allows for automation, really no kind of manual touch required to bring in an asset and make it work for your system. I'm going to run through these pretty quickly, but there is, a shameless plug. We have our 1 hour session tomorrow. I think it's 11 to 12 over at the main building that goes deep into the body anchoring. But for example, for footwear, if you wanted to place it and have no clipping or minimal clipping and bring an occluder in, we defined 6 points, actually 7 points within the shoe. One would be on the kind of the sole heel for the placement, and then around we typically get a lot of clipping that happens around the ankle, especially if it's like a photogrammetry capture, and in the front on the sides of the shoe. So defining these as a new glTF extension that has standard naming and standard points will allow anybody to take a shoe, kind of interchange it within different brands, different social platforms, and you would be able to place it kind of with confidence, automatable every time for a scaled number of assets. Like I said, I'm going to run through these pretty quick because I only have 10 minutes. The next one we focused on was eyewear. This one we actually had 3 points for the anchoring. One would be on the nose bridge. The other 2 would be on the top of the ears. The reason we don't have 3 on the shoe is because the planes, the X or the Y and Z planes kind of help with the orientation. But for eyewear, if it's flat, you could get the eyewear kind of pointing down lower at the bottom of your ear. So we wanted to have that positioning of the angle of the eyewear with the others. And then we saw some clipping in that other one around kind of the bottom of the cheek and the occluder. The next area that we wanted to focus in on was the wrist. We've had some watch try-on and bracelet as well. They're similar idea here with one extra item. If you see in the green, we now have something called an attachment, which is a fixed attachment. But you have the anchoring, which is where the placement would be. Then you have a few points kind of for the fitting and the clipping, which would be around the edges. And then the idea would be if you wanted to do almost a true to size watch face, if you're purchasing a watch, you kind of care about how big the watch face is. You don't want to necessarily scale that up or down as you scale the rest of the 3D model. So we were actually recommending breaking out the face of the watch separate from the band and then having the attachment points so that you can scale the band to the user's wrist, but the watch face could stay the same. This would be kind of an optional add-on as a body, glTF extension that could be used for use cases, or it could be, ignored if you didn't need to have the true to size face. And then similar for ring, again, you can be a size 10 ring, you can be a size 5 ring. You shouldn't scale the diamond up on the ring as you're scaling the product. It's kind of misleading to the shopper. So similar idea, you've got kind of one anchor for the placement, that would be in the center. You've got the collision around the sides to help with the positioning and the fitting. And then you've got that fixed attachment up at the setting at the top of the ring. I'm going to step away for a few minutes, but I'll be back for the Q&A. So if anybody has any questions around any of these, I went through them very quickly. Happy to answer. But what's the next steps? First off, we're going to actually propose this, as formal glTF extensions in GitHub and have the review to get it ratified. We'll give updates, when that as that progresses, and then we'll also be looking at dev tools to help. For people that have 3D models that have already been built, how can you kind of automatically place these, like this would be an example with the shoe to help with the placement of these attachment and anchor points. And then we're not done with just these 4. This is, just the start, and we want to kind of continue to almost everything that could be within the body. Apparel would be a major one, so that's going to be one that we'll probably focus on next, but then we also have earrings, necklaces, and something like a purse. You can have a surface placement, but we would want to kind of look at how do you kind of have that same model be for a body try-on as well as that surface try-on. So that's it from me. I'm going to turn it over to Ed, I think is next.
Thank you. So my name is Ed Mackey. I'm currently the chair of the PBR TSG group within Khronos. It's a group devoted to advancing and modernizing the state of PBR and glTF, and I'm here with Henrik from Autodesk. He is an expert in Material X and several different PBR systems, and so we're going to explain how development is going in PBR. You may know we started with the release of glTF 2.0 back in the year 2017. We started with a very simplistic, by today's standards, material metal roughness workflow. We had ambient occlusion, we have a normal map, emission, that sort of thing. But pretty quickly it started to become apparent that, at least in that first publication in that year, we hadn't specified the math maybe completely precisely, and it was starting to look already dated by 2020. So in 2020, we formed the PBR TSG. It's a group that split off from the main 3D formats working group with the mission of really nailing down and modernizing and maturing our definition of PBR. We were helped a lot by one of our members, Dassault Systems, and their enterprise PBR team. They essentially wrote a new mathematical definition of that core metallic roughness material model that we were using and made it much more specific. And we also released various extensions to that model that year, clear coat, sheen, and transmission. And then in the following year, we did a few more things. One of the things that's not shown on this slide is that back in 2017, we also had another extension, which was a specular glossy extension, but it was a whole different material model. It replaced the metallic roughness core workflow with something completely different, with diffuse and specular and glossy. So in 2021, we deprecated that, we archived that, and we introduced a new specular extension that integrated the specular channel as a new input into the existing core metallic roughness material. So now we don't have 2 separate PBR materials, now we just have the core metal roughness material, and we have these glTF extensions that sort of add on to that single material. Some of the other interesting stuff we did that year was the index of refraction and volume. I'm going to try a live demo, if I may. We'll see how a live demo goes. This is our, oh yeah, can I, all right. We'll see how well optical mouse works on glass. Yeah, optical mouse is not going to work on glass. Oh, I'm not on the right monitor. I'll get it. Yeah, it was on the right monitor earlier. Sorry about that. There we go. All right, so this is the glTF sample viewer. You may have seen this online. It is, that was not what I wanted to do. Let me just push that right back down. This is rendering in real time in WebGL. And this particular model is from Wayfair. Thanks, Eric, for contributing this sample model. to us. The lid of this olive jar is using our transmissive volumetric glass material. And if you look particularly at these 3 olives right here, by the way, the olives are apparently sold separately from Wayfair. They don't come with this dish. But if you look at these 3 olives, the glass is sort of distorting them where the lip hits it. And then also, if you look even at the background, you can see this red column here is full of straight lines, but when the glass comes in front, you may see the red line distort. And if you've played with rendering engines before, you know this is not something that simple alpha blending is going to do for you. There's no ray tracing here, it's just WebGL. We're actually rendering, in this case, all the opaque objects to a texture, and then the transmissive object is doing a texture lookup into that opaque scene and is able to distort it like that. Let's see if I can get back to my presentation. So that's an approximation, right? That's not the way a path tracer would do it. That's an approximation that we have for a real-time rasterizer. glTF does not tell you you need to use that particular approximation or any other approximation. glTF just tells you what the material is made of. And if you want to path trace it for real, you can do that. If you want to run a wacky JavaScript approximation and get it done quick, you can do that too. I'm going to come back to that topic in just a minute, but first, let's finish out my timeline. Last year, we had a couple more extensions released. We had emissive strength that gives things cool glowing colors, which is fun, and we had iridescence. That's another Wayfair sample model there. It's a lamp with a very, very thin film layer on it that has sort of a rainbow shine to it. And that actually comes from the interference of light reflecting off the top and bottom of a layer that's so thin that it's as thin as the wavelength of the light. And it's creating those rainbow patterns, which is pretty cool. So this year, just 2 weeks ago, I think, we ratified our anisotropy extension. It's our newest PBR extension. It specifies for the first time that the roughness of a material in glTF does not need to be the same in all directions. The roughness can be higher in a particular direction than another, and that changes the way the reflections work. So across the bottom row here, you see a sort of a brushed metal lamp, and you can create that brushed look even just with a simple base color and a normal map, but the reflections aren't right. The reflections are just sort of blobby. And what you really want for a brushed metal is you want the reflections to organize into those columns. And that's what this extension is doing for us. This is the parameterization. You know, the next PBR standard over can show you their own slide with their own parameterization of anisotropy, but what I would like you to understand more so than the details of this parameterization is the process by which we got here. We have a group within Khronos. We have these different members, and they were looking at all of our drafts, right? So we had Mike from Adobe. He's a developer on the Adobe Substance Stager team, and on his work machine he had like a dev build of Stager, and he was trying out the different drafts that we were proposing for this and seeing how well they worked in the Adobe product and showing us like sample renders from his dev build of the Adobe product. And at the same time, we had Emmett from Google was wanting this for his model viewer tag, and so he was prototyping it in Three.js and showing us how it looked in Three.js. And Gary from the Babylon team at Microsoft was showing us how this looked in Babylon. So we have these different needs. We have the real-time WebGL, make it run fast on a little battery-operated GPU type crowd wanting this to go quick. And we also have the real path tracers, you know, the Dassault Systems Enterprise PBR team, the Adobe Stager team who wanted like the perfect path traced, you know, beautifulness and not the quickie approximations. So, whoops, wrong button. So this is one of our available approximations for anisotropy. This is how Three.js and Babylon.js are currently doing it. And it's, they actually got it done without creating a performance hit by avoiding any extra texture lookups. Normally, if you want to blur in a particular direction, you need many more texture samples in your shader, and that hurts performance. We found after much experimenting that we could essentially just stretch the IBL and get a pretty good approximation. And in fact, if you look the top rows, it looks very similar to path trace renders that we have, where stretching is almost the same as blurring. The bottommost row here is with no anisotropy at all, so that row is the same too. But the second from bottom row, you can see where this approximation breaks down, especially on the sphere on the left side. You can see there's a building visible in the IBL in that environment image-based lighting that has been stretched instead of blurred in a particular direction. So some of the real-time frameworks decide that, okay, well, that one little spot there is broken, but I still need to render fast on a mobile phone or in a VR headset, so I'm going to accept that little bit of breakage on that one sphere and just go fast. And then we have other products like the path tracers that say, no, we're just rendering this perfect, and we're not going to use this approximation. So with glTF, we don't tell you how to render. We tell you what the thing is made of, right? We pick our PBR parameters to tell you that if this glTF asset were a real thing in the real world, this is what its physical properties would be. And if you need to render it quick, we may offer an optional side texture map like ambient occlusion or thickness that says if you're going quick and making these fast approximations, you can have this helper texture map, but you don't need to use that in a path tracer because you know what the real properties of this thing are, and you can decide, your rendering engine can decide for itself what rendering strategy it's going to take. Be it the long-winded, make it look absolutely perfect versus get it done quick. And that's all done with the same glTF asset. And this is part of what sets our definition of PBR apart from some others, is that we are not saying, okay, well, the artist gave you a node graph with 1,000 nodes, and each of those nodes specifies some particular piece of math, and you need to follow all that math if you want this thing to render. We don't do that. We say, here's what the material is, and you get to decide how much approximations or not you're going to take on your way of rendering it there. Up next on our roadmap is subsurface scattering and diffuse transmission. This has been probably on the back burner for a while, but it's going to come to the foreground here pretty quickly. If you're an expert in this, please join Khronos and talk to us about it, because we'd love to have you on the calls. And yeah, with that, I'm going to hand it over to Henrik, and he's going to tell you about Material X and relationships with other PBR.
Thanks, Ed. Yeah, so as Ed mentioned, I'm from Autodesk. I've been involved in the glTF PBR working group since we started about 4 years ago, and I'm also involved in some of the other material-related initiatives like Material X, Open PBR, Standard Surface, and so on. So one thing that comes up pretty frequently is, how does glTF PBR relates to all these other things I hear about, like OSL, MDL, Material X, Open PBR, and so on. So I'm just going to quickly try to explain how it relates to some of these other initiatives. So hopefully it was clear from Ed's description, but the glTF PBR model is an Uber shader model. So it's based on the same principles as some of these other common Uber shaders, like Adobe Standard Material, Autodesk Standard Surface, Blender Principle, Dassault Enterprise PBR, USD Preview Surface, and a few others. And that's a different approach compared to, let's say, the shading languages like in OSL or MDL, where you can basically create your own shading model from small building blocks. Whereas in the Uber shader case, you have a fixed material model. And there are several advantages with that. It's much more artist-friendly and intuitive to use. And as Dan explained earlier, that's really a key to get adoption for across multiple different industries in creating materials. And it turns out that it's expressive enough for the vast majority of materials that you will need in practice, so you don't have to go to the length of creating your own specialized shading model. And it also, like Ed described, makes it very portable. You can scale from like high-end offline to various real-time targets, and since you have a full understanding of the complete shading model, you can make informed approximations. Whereas if you just get an arbitrary shading graph of various different nodes, it's hard to reason about and make good calls in how you would approximate that for a real-time environment. And if you want to know more about how these different shading models compare to each other and what parameters map and how they might differ in between the different Uber shaders, Ben Houston has an excellent spreadsheet that kind of breaks down all the common models, and you can scan the QR code there. So yeah, that's a highly recommended resource. So one question we got early on when we started this work is like, why? Okay, there are a few popular PBR Uber shaders out there. Why wouldn't we just adopt one of those for the glTF work? But they weren't widely supported across different vendors, different tools, and especially real-time engines. There was like no consensus in how to implement some of these effects that you saw earlier, in a practical way. Because again, going back to the earlier talks, the consistency that a product looks the same in all the different viewers and different browsers, different engines is really key for some use cases. So we did go with this incremental approach through various extensions. And while the extensions themselves are based on physical properties and not tied to any particular implementation, we needed to make sure that it is practical to implement it today in real-time engines. So for each extension, we have multiple different real-time engines supporting it before we ratify an extension. And the way we tackle that in the timeline that Ed described earlier was which extensions would, or which phenomena of materials would provide a lot of value and also are mature. There is a common understanding on how to parameterize them and how to implement them in both real-time and offline renderers. So that's why we started with clear coat and those effects that were would bring a lot of value, but also relatively straightforward to agree on the parameterization and implementation. Whereas subsurface scattering is still on the backlog because there's more discussion needed before we can kind of nail that down. But I should say that all these other popular PBR models were used as a basis when we defined these extensions. So if you author assets in any of these common models, they very easily map to glTF PBR. So you can easily publish them for downstream workflows, and vice versa. If you have an asset in glTF, you could map it to these models if you have other workflows where you need to do more editing or flexible workflows. So another popular open standard around materials is Material X, but there's a significant difference here. Material X is not specifying a PBR model in itself. It's this flexible graph-based system to describe both patterns, so texturing or parameters, and also a way to express various different PBR shading models. So on the left-hand side here, you see like a pattern graph, which consists of image nodes and procedural math nodes that drive the input parameters to your shading model, like base color, roughness, IOR, and so on. And that graph could be just one node, like one image texture, but it could also be image texture plus some scale, or it could be arbitrarily procedural networks. And then the second piece is this PBR graph, which can express any shading model, such as the glTF PBR1 or standard surface or the newly announced open PBR1. And the final component is this optional shader generation framework that allows you to take these graphs and turn it into shader code that you can execute in your engine. And that out of the box supports the common languages like GLSL, OSL, MDL, metal shading language, and so on. So, can I go back? Yeah, so if you look at the middle part here, the PBR graph, we have that for glTF PBR. So in the last year, I think this was work from Dassault, from Tobias. So there is a full Material X graph for glTF PBR, which allows you to use this material model in other tools and other downstream workflows, renderers that support Material X, or material editors that support Material X. You can open the PBR model, and you can, if you choose to, modify it or extend it. And one thing we're looking at right now is to see if we can take some of Material X's procedural capabilities and adopt those for glTF. And apart from adding some additional flexibility in just procedural texturing in general, it would also bring some benefits with transmission size, because you can express high resolution of patterns and textures with a smaller footprint, which will help with both transmission and potentially also rendering on low capability devices. But this will still just be for the procedural aspect, so that will plug into the glTF PBR model and be compatible with everything we've showed here so far. But this is still early work, and one fallback you could have if your engine doesn't support interpretation of the procedurals, you can imagine baking that to a texture atlas for your texture inputs, or material inputs rather. So yeah, some work happening in the glTF PBR working group right now on Material X. So yeah, if you're interested in this work, please come join us. So that was it from the PBR side of things. Over to Interactivity.
Hello, my name is Gerald Guyomard. I work for Adobe. I'm a software engineer, and for the past years I've been involved in various interactivity components. So today I'm going to present the work of the interactivity group at Khronos for bringing interactivity to glTF. So before starting to talk about the specification, let's just recap exactly what we mean about interactivity. We have seen previously in this presentation, thanks to Dan, many very good examples in 3D commerce, and I'm going to start this presentation with a very simple example. A typical use case of interactivity on the web, for example, on a commerce website, is trying to sell you a coffee machine. How am I supposed to? So what you see here is a coffee machine, right, where there is a model button where you can change from one model to another. There is also a color button where you really want to pick the color you want for the coffee machine. And so that's really that interactivity. It's something that where your content dynamically reacts to your user input. That's something that makes your content more compelling, and that's something that makes your content brings your content to life. Next slide. To click outside. Nope. No, this one is done. Okay, here we are. So, glTF is a file format that can describe many things, like a node, mesh, materials, and so on. But it's mostly today about representing a static scene, right? There's no internal rules that can represent the logic of your interactivity. Until now, interactivity was kind of custom made, and it was up to every application importing a glTF to write this interactivity logic. And for this reason, your interactive content was not portable. Your interactive content was only working in your application. Okay. So what we are proposing today is a new extension that, on the left, what you see is exactly this. No, is only the glTF as you can export today. Just a bunch of static objects, the coffee machine, the buttons, and the only thing you can do if you import this, for example, in a web viewer, you can just orbit around the camera, and that's it. As soon as you adopt this interactivity building block, you're gonna be able to do exactly what I just shown in the previous slide, a fully compelling, interactive, rich experience. So this new glTF extension, it's all about providing a blueprint for it goes from, I would say, smart assets, just like a door, a simple door, where when you click on it, it's either open or close, or it can be even more. It can be bigger than this, like developing little games or a full-fledged 3D commerce experience. So when we started this work of figuring out exactly how we could encode such interactivity logic in the glTF, we looked at exactly what people do these days for doing that. So I would say on the left side, it's the hardcore old school way, you write code. So on purpose, I chose an example on the bottom left corner of this slide that is pure C++, that is just a snippet of code that just says, I'm waiting the user to press the space bar. When it happens, I'm continuously rotating the object by 30 degrees every second. Okay, so it's scary and it's for a good reason, because it's for engineers, it's C++, it requires some kind of skills. And so it requires some skills, and you obviously have some portability issues. By writing this kind of code, you are not sure it's going to run anywhere. So in the early 2000s, a new kind of programming emerged and became very popular these days until now. It's what we call visual programming. So I don't know if you have kids, but I always mention this example. For example, MIT Scratch is a very nice way for kids to learn how to program. And instead of writing line of code where you are struggling with resolving compile errors, syntax errors, you are given a set of building blocks, like Lego blocks, that you would assemble, and then you would graphically create your execution flow and so on. So it's much easier to learn. We can just target a much wider audience, not only engineers, but also technical artists or artists. There's no syntax to learn. You don't have any compilation error. It's more portable, because by design the level of abstraction is much higher than writing raw C++ code. And it's more secure, because you can only do what you are allowed to do thanks to the atomic building blocks you are using. So as an example, in the bottom right, this is the exact same code that you see on the left in C++, but expressed in visual programming, made with the Unity visual scripting module. So you will see it's like a set of blocks that you would assemble and link together. So as I told you, visual programming is a vast topic. There are various ways of doing that. We focused on the node-based graph approach, which is a comprehensive. It offers a comprehensive set of building blocks where you can define your custom variables graphically, you can read them, you can write to them. You can also query the world state. I have a node in my SIGGRAPH, I want to get the translation of it. And also, something super important to understand is you can you can define carefully your execution flow with a branching condition, like the if-else in regular programming. And that is the thing that is very popular these days, that you can find in such tools like Unity, called visual scripting, or Unreal in the blueprints, Omniverse with the OmniGraph, you name it. So I'm talking about this node-based graph design because it's exactly what we decided to pick for the interactivity extension for glTF. So because this kind of approach is the good trade-off between accessibility and power. It's accessible enough not to be a niche for technical people. It embraces more people. More people are likely to adopt such a technology. It's extensible because we provide a bunch of standard building blocks. We call that the nodes, but it's gonna be up to you to define your own node to really adapt this thing to your needs. And it's compatible with visual editing. So to be careful, we are only providing specification on how things could be made. But it's a solid foundation for third-party vendors or developers to build their own visual editor, respecting the rules that we set for this extension. So that's the only technical slide. Don't be afraid. It's just to give you a very concrete example of what visual programming is. So this example is all about enumerating some numbers between 1 to 5. So 1, 2, 3, 4, 5. I'm okay. And it's gonna, for every numbers, we're gonna send an event. An event is just like a message, or think a print. That's the same principle. That's gonna say odd or even depending on the value. So 1 is even, 2 is, no, 1 is odd, 2 is even, you see? I can be wrong too. So you see the various color coding on this graph. It represents the categories of this node. So you have like a node is defined by its type. For example, the first one you see on the left, the blue one, the life cycle on start, is going to be activated. So the action corresponding to it is going to be run at the very beginning. You run the experience. And you see this little black links between the nodes. Okay, you have two kinds of links. The one with an arrow tip are what we call the flow links. That's the thing that's gonna define your flow of execution. So, for example, here on the on start, I'm starting my for loop. Okay, to iterate through 1 to 5, with two outputs, two flow output, loop body, the one that's gonna be executed for every value from 1 to 5. And then the flow branch is a if, think if, right? And we are doing some computation, the modulo of 2 to just figure out if it's odd or even. And depending on that, we're gonna just, at the very far right, send one event called odd or even. And at the very end, so when it's done, you see the other output socket in the for loop done. We are activating a flow delay that is just pausing the graph for a while, for 2 seconds. We're gonna then display done. So that's just a rough example of how you would design your logic. So now, what can't you do and why? We are aware that there are some limitations, just first of all because that's the first version of this extension, but also because at the core of our consideration we have these 3 keywords: security, portability, and ease of implementation. Okay, so because of security, we don't want to the people implementing this spec to create some buffer overflow or whatever by often due by dynamic allocation. So that's why there's no dynamic allocation or object instantiation. That means that basically, if you want to show some objects that are not present at the beginning of the experience, they are there, but they are just hidden. We just need to trigger the property visible. There's no network access, there's no file system access, and there's no multi-user. So that's the only very beginning of this promising extension, and because by design it's extensible, we hope that in the future it's going to be more complete. No, it's up to you.
So we'll talk about Composite Scenes. This is new work that Khronos is doing. Pretty much just started this project, even though the initial idea to us came from Adobe about 1.5 years ago. They brought the idea that included interactivity and composite scenes, where you take multiple objects and include them into one scene. This is something that Dan talked about as a need for 3D commerce. And it turns out the need for 3D commerce started developing just about the same time that Adobe brought their potential solution of it. And their solution was based on their work that they originally did as part of Arrow. So those familiar with the Adobe product suites will recognize the Arrow. And if you really understand what's going on and understand Arrow, you may see the connection there. So there's several different types of composition. There's a traditional LOD, in other words, as you get closer to the object from your viewing camera, you get more detail. And that sort of drives the whole concepts of what these are doing, but there's variations on that. There's time-based. In other words, when some object appears just at the beginning of a whole sequence, particularly an animated sequence, and doesn't show up again, that's something that you can then unload right after it's done appearing and you can save your memory. Alternatively, there's the equivalent where it doesn't appear till towards the end, and you don't want to load it up front, delaying everything else from starting. So you load it, you start everything, and then you load it as you go. There's also environment-based, and I'll get to that one in a little bit more detail. Streaming of large models or progressive loading, that's something that becomes very important when you have very large models, and we'll talk about that particularly in a geospatial case for that coming up. Smart loading is an interesting concept, and this is where you load the material that you need to see dependent upon what the user's device and the user's network connection speed is. So if somebody's working on a desktop in a highly hardwired connection area, then you can pretty much load everything in full maximal detail starting from the beginning. But if they have a low capacity device, low capability device like a phone on a very slow network, you don't want to load everything. You want to load only the most important stuff. So there's a detection there, communication between the client, in other words, the user's device, and the server as to what to send down the wire. And then, of course, you could always change or delete objects as seen. That's sort of the basis of room planning. So the geospatial case here is where you load in a very low resolution piece when you're far from the object. And it's divided up into hierarchical level of detail. Sometimes it's a quad tree, sometimes it's an octree, depending upon the particular application. And as you approach one section there, you load more and more details. Other pieces that either are further apart or so far away that they're not in the view frustum get dropped out of memory, or just pushed off to the side, so depending upon what sort of level of responsiveness you want in your application. Sometimes there are things that you don't want to show everybody, or you can't show everybody, or you shouldn't show everybody. For example, in this room, behind, above the ceilings, there's all sorts of HVAC and electrical plumbing lines. We in the building, as a user of this room, don't care, don't want to see it, probably even should not see it. But if you're doing maintenance, you need to know about that. And it's not so much in a big hotel room, but when you're getting into industrial facilities, it becomes much more of an issue, making sure that the pipes are carrying the right things, or that you're not about to open a pipe that's carrying high pressure steam. In the last case I'm going to show with pictures is the room planner. This is where you select several different objects, even potentially from different suppliers, and you integrate them into one room, either in a virtual sense like this video shows, or more common, as many apps now do, is a virtual augmented sense, where you say, okay, here's my living room, I want the couch here and the table here, and it puts those there. Advanced cases will actually learn to remove existing objects if that's something you want to remove, eliminate from the scene or from your room in the future. So the work to date, and this was started really in May and represents about 1 month of work and then additional analysis of the results. It was a demo that we did for AWE. The contractor in this one was UX3D based in Germany. They took their existing sample viewer application, which Ed showed much earlier, and extended it to support multiple scenes, multiple objects. This was done at the time. The file format was known as glXF, and we don't talk about much about that anymore, so we're trying to go to the composition format, which is glTF-C. But in this particular demo, you'll see the glXF, so don't worry about that. Eventually, we want to get to the point where we include interactivity, but we don't have that for now. I have a video, but it's on the other screen, so give me a moment, please. This is the starting point of the application, of the demo application. You can select the other scene. This is the 3 objects comprised here. Then to illustrate that, we manually edit the glXF file here by adding in the additional asset and additional node, which will show up here. There's the new asset, which will be glass hurricane candle, and the additional node gets stuck into here, similar to the lamp node, just like right down there, and it ends up putting it onto the scene. And once we reload, so it's there. I know this is not really high-tech and really cool, but it was important for us to be able to establish that we could actually do this, and it worked well. This represented less than a month's worth of work, starting from scratch on the application as the extension to Sample Viewer. And this is available online if you ever want to try the results and push things out. By the way, all these slides will be available online, and most of these have embedded links in places so you can track them out. Timeline for getting them online will be shortly after SIGGRAPH. So next up is we have work to do on the specification, defining it better, how it works in just the straight composition form. We have several different types of composition to include, and exactly which ones we start with is still yet to be determined. 3D Commerce, headed by Dan, is setting up the use cases and the priorities, and that will be pushed forward for this particular project. We'll continue on the prototype development. UX3D is supporting this work. Their job is to create the prototypes as we need to see them, work out the use cases, find out where there's holes or inconsistencies. So now I'm switching hats, and this is the tooling section. I am chair of this, and it's technically a TSG, but that's kind of too much detail. So the tooling mission is to support glTF through outreach and education and developing and supporting the community. We create projects and execute them in a number of different situations, and in particular for these 5 bullets listed here. The biggest one here is that we've accomplished recently has been education areas. The members of the tooling group are listed over there on the left. This is mostly the people who have been very present over the last few months. The contractors listed on the right are those who have been key to developing various aspects of these projects. A number of these works have been presented at other Khronos BOFs earlier in the week. And a list of the project collections is here. This is not the list of the individual projects because it doesn't make much sense. But generally speaking, we have focused a lot on making sure that the software that we do produce is maintained, and that's seen in the Blender support and the glTF sample viewer support. But we're also continuing to develop new projects, some of which are extensions, like the sample viewer that we used for the composition, and also the sample viewer was used as the base for the glTF compressor. Other projects create brand new software, such as the asset auditor. The projects tend to fall into these 4 categories. And I built this before really testing it out on this particular display. So it leads to a little bit of awkward situations clicking here. In the content creation section, many of these projects show up in multiple categories. So you'll see the same icon reference there. I will cover the details of these projects in a little bit. The first one there, always going around top left and clockwise, is the tutorials project. We'll go have a quick video that condenses the tutorials by a factor of 30 or so. Sample model repo, the compressor, and asset auditor, plus Blender. We continually not only just maintain the Blender plugin, but we continually advance it. The latest Blender plugin supports everything, all the extensions that Khronos has developed or ratified, except anisotropy and iridescence. Those two came out after the software was started for that latest release. They will be included in the release later this year. So the pipeline and distribution, this is the place where once the content is created, organizations need to optimize the content for better distribution, handle multiple different platforms, getting it out to the users, making sure that things work at the user end. There's a number of tools here that assist in that category. Going across the top again, the model repo, KTX tools. These allow very detailed choices of KTX compression. They run both pipeline methods, where you can run them from the command line and just process all your entire asset library, or as the experimental side, more for the glTF compressor, which is the next line. I'm sorry, that's scene composition. A big item today that we were talking about this week is Khronos has released an RFP for glTF on iOS. This is to support the display of glTF models on iOS using both virtual mode, in other words, straight on the screen, and also in augmented mode where you use the device's camera. So the RFP is available. It's a public RFP. It's a relatively small project. We're looking for lots of submissions on that RFP. The deadlines for submission is later this month. Blender support, always supporting Blender. Metadata, especially for commerce cases, allows you to connect up what is displayed to the user back to information on the screen, or carries, let's say, non-modeled information such as packing sizes, finished size that's not necessarily apparent from the model, extensions or things like that. More compressor, sample viewer, and asset auditor. Education, again, a lot of the things, the tutorials show up here again. And the new one, the new icon, new image on here is the ecosystem, or also Project Explorer. This was released last week. It is the web version of the Project Explorer, which runs under GitHub. This is a much easier one to use. It makes it easier for people to add in new models or new references to do that. And we'll take a look at that in more detail a little bit. Not? Oh. The last category is the futures. These are things primarily needed by Khronos, but sometimes also working for the futures of the community. Composition is the big one here. But we're also looking at metadata advances and starting to categorize metadata in a manner that can be easily shared amongst different contractors, so providing a specification for that. So I want to run the tutorial video. These are videos available on YouTube. And this is a very shortened version, a shortened Reader Digest version of the videos. There are 5 videos. The first 2 are essentially the same ones, but with different lengths depending upon your application. Then we go through 3 extensions, Clear Coat here. And all these use Blender as an example, and they show you how to create that extension, how to use that extension within Blender. Transmission. And there's also, with each video, a little bit of an education portion, exactly why you would want to use that particular extension or that effect. And of course, how it looks before and after and multiple points along the path, from initial version where you just had the model to the final version where you're using all the feature of the video. And finally, the volume extension, which Ed referenced in the olive dish. And this has a lot more education component to it. And must point out that these models were, for the most part, all done by Eric from Wayfair. Thank you, Eric. Except for Suzanne. And there's, during the video, it's not just this quickly catch it as it goes by. This is running 2 to 4 times faster than the video, and there is narration that goes with the explanations here. The video projects are continuing. We have a new set of videos coming out, or actually being produced for 3D Commerce. They will involve not quite so much technical detail of how you do things, but of more of the issues involved with creating, dealing with 3D models in commerce. And there'll be additional sets of technical videos coming out for the new extensions and some other technical topics. So we have, Khronos had the glTF sample model repo that has been revised and upgraded. It's now called Sample Assets. And this is the homepage. It's all on GitHub, meaning everything here is public. We did a thorough license categorization of this so that clearly identified the licenses involved with each model. For the most part, these are all CC BY. Occasionally, they are CC 0, which also means public domain. They include a lot more means for easily accessing the model, so you don't have to download the model to show it. All these models have links in them directly to show them in Sample Viewer. Let's see, we talked about the RFP. If anybody has any questions on the RFP, come see me, myself or anytime, and we'll have contact information. It is available. Go to khronos.org, and it's under developers. Yes. Sometimes you get too lost in the details. RFP means request for proposal. So it's to ask people to write proposals for how they would solve this problem within the schedule and the budget listed here. Project Explorer, here's the quick version, but this is now on the web. It's ecosystem.khronos.org. You can add in your own projects here. Anything that contributes to the general knowledge of glTF or how it's used, or perhaps even commercial projects or open source projects are all equally welcome. The add project is up in the top right. And once a project is in here, you can update it. All this is curated, so just because you submit or add an update to it is not going to immediately appear on the website, so not worried about spam at the moment. And we talked about all these. So this is a text version of the future's work coming up. Composition is very high on that list, and so are the tutorials and other videos. And always, as indicated many times, support for Blender. So if we have Blender users out here, know that you will always be kept within 6 months or so of the current and most latest releases of whatever's in glTF. That's my contact, in case anybody needs it. And now we go to the Q&A. Thank you. Okay, if you have any questions, please use the mic on the floor so we can pick it up. It's right over here.
Thanks so far. A question about interactions. So it's great that they're inside of the glTF and everything, but maybe I want to, depending on the situation, build my own GUI like on a web page. So do you have a proposal, or is there some guide plan for engines how to implement an interface to query what interactions are possible and to make it possible to have external buttons or something to trigger them?
Yeah, so you can define custom events. It's defined by name, so you need to make sure that you don't. There's no name clashing. So that could be your company name / the ID you want for the event, and you can both receive from the graph or send from the graph. So every event can store some payload. So again, it's glTF, so it's all about JSON. And so that's a nice mechanism to bridge the graph with the web page. Now the thing is, I didn't mention here because it was a shortened version. Is the example I just showed was just a simple for loop that was just printing in the. Or it was most of the time, if you want to deal with interaction, you want to address the scene graph, getting the position of a particular node and so on. And so how do we solve this issue is basically glTF being a JSON, it's a tree, it's a data object model that you can address with a JSON path. So that's why also this extension relies on the ratification of another glTF extension, the KHR animation path that is I will not go into detail on this one, but basically it's something where if you want to get a translation, I would say, of the node number 7, because in glTF every object is an array, and then you identify an object by its index. That would be something like /node/6/translation. Because if it happens, you open this glTF inside a code editor, you will notice that all the nodes are stored inside a node entry in the JSON. And so it's going to be up to every runtime that has its own game engine, I would say, that may not share this organization of the scene graph, to provide some adapter to map that to your own data structure.
Okay,
Maybe
thank you.
I went beyond the question.
I have a follow-up to the same question. So the flow graphs, the nodes that are used in the flow graphs, are they part of the standard, the extension? Are they so let's say you have a for loop or an if loop.
Yeah.
Are they?
Yeah. All the things that you could expect from I would say basic flow. So if we talk C or procedural programming, for loop, while, We don't say if, because we try to reuse the same convention used in Unreal and all these tools that say a branch. So for example, a branch, you have one input value socket that is the Boolean, the condition that could come from a previous node, and you have two outputs when it's true and when it's false. So you can, by doing that, you can do something you would do by doing a if something else. And there are various ways. There, I mean, everything you may find something missing just because we don't want to bring too many atomic blocks at once. And our mantra, I would say, with each, we won't define in the standard a block that you could implement yourself by reusing more atomic components.
Oh, thank you.
My name is Johannes Beer. I worked on a couple of original proposals I had. We worked on this extension proposal like 3-4 years ago, and the idea was to compose extension, and we included the composability directly into glTF and not add yet another format. So with the GLC file that you have right now to do composes, you have a different format. And the links to other assets is not in glTF or GLB directly.
I didn't quite catch the question. Is it, are you wondering, are the leaf nodes forced to be glTF?
No. Why did you create yet another format and did not use GLB or glTF for the links? You could add, what we proposed is that you add it directly in the node graph inside of a GLB or glTF, and that would be much more efficient. So if you have large composition, for example, you could use a binary compression of GLB, and with the external file, you cannot use the benefits of ASCII and binary compression.
We needed to handle the situation where the resources could come from multiple different locations. And
yeah, but also with links inside of a GLB, you could, or from a glTF, links to.
In addition to the glTF-C, which I talked about, there will be a glTF-B, so a binary version, which will support rolling everything into one file, much like GLB does currently.
Okay, so it gets even more complicated. Now you need 4 variants.
Now, at that point, though, we are not, this concept has been decided as a concept. We haven't even started on how to write that up as a specification.
I might, it works. Okay, I might maybe add to this. So idea for glTF-C actually to open. Does it work? Oh, okay, sorry. Yeah. So idea actually is bring even more flexibility. glTF unfortunately doesn't serve this because glTF it's pretty much established spec, and you cannot avoid add more information into it because you have to respect the spec. glTF-C in some sense is way more lighter and allows you to use any different resources reusage. So it's up to you how you'll share the cache or something else. So we want to keep this core for glTF-C as lean as possible and introduce additional extensions that you can put any kind of possible combinations that you want. So we just want to open more flexibility by default.
Well, then, okay. But the argument goes in both directions. You can also say just build simple GLB or glTF files that just contain links, and then you would have the same.
Unfortunately, that's impossible because glTF, again, it's established. You cannot just create empty glTF that contains only links. It will be not conformant to glTF spec.
Yeah.
And then, again, we have glTF, glTF-B-C, right? So, even I get lost. Yeah, we have the binary representation. That will be actually compatible it will be next version for GLB. So that will be unified between GLB and composition binary representation. The more details are incoming.
Okay, good. I just look in the spec.
Thank you, Johannes. Any other questions?
Yeah, someone's coming
Yeah,
up.
someone's coming, great.
Hi, so kind of piggybacking off of the last question, in one of the files that you showed today, there's in the GLTF spec, there's the assets panel, or the list of assets, and those had external links in them already. I was just wondering, what is the current use of that? Because it seems like it might already provide some of this like functionality of allowing links for loading of external resources and doing scene comp in GLTF as it is now.
But that was exactly example of this new GLTF-C file, actually.
Yeah, but aren't assets also in GLTF right now?
No, the GLTF might have the reference for the buffer views or textures, but it's not like generic. You cannot embed another GLTF inside GLTF.
Okay. Okay, so just to be clear, the assets, like nodes, materials, meshes, there is an assets category as well in the GLTF spec as it stands now? Yeah,
it doesn't. That's pretty much GLTF-C. So only one requirement for GLTF-C is just listen the nodes. That's it, nothing else. That's why it's different from GLTF, because GLTF requires more information.
Okay.
Hey guys, good to see everyone. It's Patrick. I have yet another composition question, but it's just a vocab question, maybe a comment and question. So one, look, I'm a big believer in the external references. We actually had it on the roadmap about 10 years ago. We just had to cut features for 1.0. My concern is with USD doing composition in the VFX world and all that means for the layering and just that big complex world. I'm afraid there could be some confusion if GLTF also uses the term composition for this. So just any kind of insights on the rationale for the naming and if we'd be open to other naming.
Maybe I provide some and then someone else will continue. So for us, that was like a battle between, we have like many names like experience and then scene description, something like this. But then we figured out we have so much different use cases that basically the composition is the best word describing this. Because that can be just exactly the situation that will not create the new scene graph or something. Like literally you have like an asset that use like two different textures and we want to be optimal for the browser performance, for example, for effective cache. And that's exactly the file that the composition happens. That's the only one single point, but we know actually for your asset, you will get those variances. And that's how we picture the composition. But it's my technical point of view. I'll pass over to Leonard, if you want to add.
No, the caching, also the user decision controlling what goes in there. So this is along the same lines as USD composition, but it is fundamentally different because it supports the last minute, last mile choices of what goes to compose a scene, like you would do in a room planner, especially if you are a generic room planner which can pull assets from multiple different vendors. Now, your comment about the name composition, I think it's taken. I'm not sure how well we can, what other suitable terms there might be out there. If somebody has a suggestion that seems really great, we'd love to hear it. But really soon we're going to have to start locking things in.
Got it. Okay, so I hear maybe it's a name in progress and we'd be open to input from the community. Is that what I'm hearing?
We kind of decided, but if you have strong opinions, probably we can decide something else.
So just my concern is, as we work for more USD, GLTF interoperability and collaboration, that if the USD community hears that GLTF is adding composition, that immediate reaction that they would have would probably not be positive.
That's why we call it glTF composition. It's not just composition.
Okay. All right. Well, I'll try to help facilitate some alternative names. Thanks,
Thank you,
guys.
Patrick.
Thank you, Patrick.
Just call it a bunch of stuff.
Yeah, you're the best. Andy.
Would that be BOS? In which case, you might as well call it BOSS and just call it the boss format?
Any more questions? Oh, here we go.
So continuing this talk on glTF-C, I'm more interested on this glTF-B that we're bringing up. How is that generally supposed to be working? Are those references supposed to be baked in? How is that working with LODs? Yada, yada, yada.
Yeah, okay, so we probably we cannot provide much details, but in general idea is we have find some flows in GLB format that we want to fix. And it's no easy way because it's out of wild, so many GLBs. And we kind of thought that's probably a great idea actually to bring those two together. In this case, that will be unified loader, a lot of runtime, nice things. And this format will basically support new GLB with those tweaks and then glTF-C as well in binary form. That's pretty much it, what I can say today.
Cool, thank you.
And that will not prevent external links, particularly when you need it to make a composited scene work.